Hey guys, welcome back to my channel and I hope you are all doing extremely well. This is lecture 18 on my linked list series. So far I covered 17 lectures. In lecture number 17, I explained what is the LRU cache and how we can solve that one. In this lecture, we are going to do the actual implementation of the LRU cache and I highly recommend you to please start watch from lecture 1 till whatever I'm going to post in this series. And I believe that at the end of this series, you will be in a situation to tackle any linked list based problem in an interview. Before going further, I request you to please subscribe to my channel and tap the bell icon to stay updated. Let's get into today's lecture. Let's try to solve this problem. The problem difficulty is medium and the problem number 146. Let's go to the diagram and try to understand it in best way. If we clearly observe, initially we are going to create the capacity, that is nothing but the cache size. Initially it is going to be 2. And we are performing one put operation. Since cache is empty, so that we can able to perform this put operations. Then I'm trying to perform again one more put operation. Still cache has size. Then I'm going to insert 2 comma 2. And after these two operations, so the LRE is going to be this. Okay. Now I'm trying to perform the get. Get means I'm trying to get the one. Means I'm trying to get this one. So when I perform the get operation on this, okay, it is going to return me the one, but the LRU is going to be this, right? Because 1 comma 1 is used, that is nothing but MRU now. So the LRU is going to be 2 comma 2. Now 3 comma 3. So cache size is full. So what is the our LRU? 2. Then let's remove this one and insert 3 comma 3 here. Good. Then get of 2. Do we have 2? No. Then we are need to return -1. Then 4 comma 4. Who is LRU? So 1 and 3 comma 3. 1 is going to be LRU, right? Because 3 got inserted just now only. And when I'm trying to perform 4 comma 4, my cache is full because it has two records. So who is the LRU? 1. Then let's remove 1 and insert 4 comma 4. But what is going to be our LRU? Now 3 comma 3 is going to be our LRU. Then get of 1. Do we have 1? No, just return -1. Then get of 3. Do we have 3? Yes, just return 3. Then get of 4. Do we have 4? Yes, just return 4. So this is all about the problem statement. So we need to implement the get method and we need to implement the put method majorly. So let's get back into the coding part and try to understand how we can able to perform this coding operation. Let's see. I'm here. Let me minimize this one. Yeah. And as I said, in order to implement this LRU cache, we are going to use two data structures. One is doubly linked list and another one is hash map. Why we are using hash map? Because we need to achieve these operations in big O of one time complexity. So that's the reason we are going with that. Now let's create a class of doubly linked list DLL node, and this is going to hold int key, int data, DLL node next, DLL node previous, and it is going to have one parameterized constructor where it accepts key and data, int key comma int data. This dot key is equal to key, this dot data is equal to data. That's pretty much with this structure, but before that let me explain you one more thing here. In order to implement this one, so as you people know, we need to have the track of when is which one got used, right? I mean, we need to predict, I mean, we need to know what is the LRU at this point of time. So for that, I am going to create one head node first, and I'm going to create one tail node also. Okay, initially the head node is going to have the key as a 0 and data as 0. Same applies to the tail node also. Key as a 0, data as a 0, and initially they form the connection. This is my head this is my tail. Then going forward, what I'm going to assume is, so if I divide this in the half, so the right of the head, okay, this is going to be MRU, that nothing but most recently used. The left of this tail is nothing but LRU. This is kind of assumptions. Okay, so I'm thinking like, okay, the immediate next node of my head is the MRU, that is nothing but most recently used one. The immediate left of my tail is going to be LRU, that is nothing but least recently used, so that I can able to delete that particular node. Okay, let's see this in the coding also. Yeah, we are done. I am going to have one global variable, capacity 0 initially, and I'm going to create a two nodes. As I said, head and tail. Head is equal to new DLL node of, and initially the key and values are going to be 0 and 0. Let's copy and paste the same for tail, just change the name to tail. Once it's done, and we need to have the map, right? So in the map, the key is going to be integer, the value is going to be DLL node itself is equal to new hash map. Now let's try to perform this constructor. Let's try to implement this one. So we are going to receive the capacity. Okay, while they create the object from the driver, so they are going to pass us the capacity. So that we need to assign to this one. This capacity is equal to capacity. Then we need to make the connection between head and tail. That is nothing but head dot next is going to be tail. Tail dot previous is going to be head, so that it forms a connection. Now the get operation. The get is all about we need to return the value of key if it exists. Otherwise, we need to return -1. For that, we need to check if map dot contains a key of key. If this is the case, we need to perform some operations. Otherwise, we need to return the -1. If it exists, what we need to do? We need to return the value of that key. That is nothing but DLL node is equal to map dot get of key and just return node. It's completed. No. If we are going to return something, okay, then we need to remove that one and we need to make it as a MRU, because this is now going to be most recently used, not least recently used. For that, we need to perform this remove operation, remove node, and then insert node. Because when you remove that one, that will be completely deleted from your map and your W link list, and when you insert that one, that is going to be marked as MRU. Okay, let's try to implement these two methods. Public void remove DLL node of node. The first and foremost thing is we need to remove it from map also. Map.remove of node.key. Then this is going to remove that one. And the next thing is we have to remove this particular node from the list. Just do something like node dot previous dot next is going to be node dot next. Node dot next dot previous is going to be node dot previous. That's all. Remove is done. Let's try to implement the insert. Public void insert DLL node of node. First, we need to make an entry in the map. For that, map.putOff node.key is going to be our key and node is going to be our value. That's all. But we need to insert this node exactly after head next, right? So if head is something like this, if head is this, then my newly inserting node is going to take place here, and my head dot next is going to be the new node, and my new node dot previous is going to be the head node, and here whatever it is there previously. For that, DLL node head next is going to be head dot next. Done. Then head dot next is going to be our node. Node dot previous is going to be head. Node dot next is going to be head next. Then finally head dot next dot prev is going to be node. That's all. We inserted a node immediately after head node. That is right to the head node. We are done with this two and we implemented the head, and the only leftover work for us is to implement this put. So when we are trying to perform the put operation, the only first thing is we need to check if this is already exist. If map dot contains key of key, if it exists, then we need to remove it actually. Map dot remove of key, and we need to make a new entry so that it is going to mark as a MRU. And the second condition is if map dot size equal to capacity. That means if my cache is full, then I need to return the what I can say LRU. LRU, as I said, that is going to be always the tail node previous. The immediate previous node of the tail is going to be your LRU1. So just remove tail dot prev. That's it. We're done. Then at the end, make the new entry. Insert new DLL node of key comma value. That's all. Then it is going to make as a MRU. That's all. Let's give a run. Uh, where is it? Yeah, return node dot data because the get is expecting us to return the integer. Head next. Sorry, some spelling mistake. Head next. Yeah, it accepted. Let's submit. Yeah, it got submitted successfully. It took 72 milliseconds. And that's all for this video. And I hope you learned how to implement this LRU cache in real time. And I hope you learned something new today. And I wish you all the best in your learning journey. Please do subscribe to my channel, and I'm going to upload more valuable content in future. That's all for the day. Thanks a lot. Bye bye.